Hello everyone, good day. Once again, it's a pleasant day to meet once again with our subject MAED 279, School Plant Management. Okay, so this time we are going to discuss Unit 5. This topic will discuss about the school buildings. No? So what are the different types of school buildings and rest of considerations to find out what facilities that includes our building and how it was created and built. No? Okay, so to begin with, we have this Unit 5, School Building, and okay, so we have here the types of school buildings. Okay, so I think this is proper if we are going to discuss first the different types of school buildings. No? So, school buildings are classified according to structure, function, and design. Okay, so the building itself is our structure, how it is finally designed, okay, by the engineers, the structural engineers, and the rest of the engineers, no? Lighting system for electrical engineers by the electrical engineers, the ventilation by the mechanical engineers. This time we have the inclusion of internet cabling, okay? So that is also very important in our new buildings, no? So for as to structure, it may be classified as permanent structure, semi-permanent, and temporary structure. Okay, school buildings, no? So we have instances that you're going to build temporary structure for lectures of our pupils, our students, no? As to function, it is classified as instructional. Accordingly, administrative and non-program classification of the buildings. No, as to design, it is classified as Gabaldon type, RPUS Bayanihan, DepEd standard modified for learning and public use school building, or they call this one as Lapos building, no, and other types of the building, okay, or types of school. As for categories, we have this according to structure, according to design, and according to functions, as we said. No? Okay, so I hope that this is clearer to you. No, according to structure, we have these different types. We have 4 types. For the type 1, we have the wood construction. Type 2, we have here wood construction with protective fire-resistant materials, 1 hour fire-resistive throughout. And type 3, we have masonry and wood construction with interior walls of incombustible or fire-resistive construction, 1 hour fire-resistive throughout. No, so we have this type 4. Steel, iron, concrete, or masonry construction with walls, ceilings, and permanent partitions of incombustible construction, except permanent non-bearing partitions, which shall be 1 hour fire resistive. Okay, so meaning to say that you have the standard of 1 hour resistive against fire of this building, no? So traditionally, this referred to us as for type 1 and type 2, semi-permanent, made of a combination of materials with concrete and 80% lumber. For type 3 and type 4, permanent, made of strong and durable materials, 80% of which is concrete. Okay, so I think basically this time, no, this is our building, newly constructed buildings might be with this type 3 and type 4, either of these 2 types, no? Okay, so according to the design, we have several types of design or types of building according to the design. We have the gabaldon type, army type, magsaysay type, so on and so forth. You have all these types here. So floor dimensions as it is described or specified, we have this dimension. Like for example, for the gabaldon type, we have the 7 by 9 meters, no? So on and so forth we have here, no? For the floor area also that we have here in square meter. So for the gabaldon we have the 63, so on and so forth we have here. We have also the FBR type of 2000. Okay, we have this more or less 56, no? Uh, we have this 56 square meter, and the gross area per place we have also here at 45 pupils per students per room in a square meter. So we have this one. So this is the distribution of our area per student, the last column here. Okay, so as for the we have also here the rest of the other types here. No, this is another type. So just go over with these different types according to the design. Okay, so according to function, okay, first and foremost, the function of our building is or should be for instructional. No, so these spaces are designed to directly accommodate the educational program. No? The basic instructional spaces for elementary schools are classrooms and work education shops or multi-purpose building for home economics and industrial art classes. That is for elementary schools. However, for secondary schools offering general curriculum, the basic instructional spaces are classrooms, computer rooms, science laboratories, and technology and livelihood education. That is for TLE shops, no? In secondary vocational schools, basic instructional spaces also included a specialized or which also include specialized shops. Okay. Other species such as libraries, learning centers, gymnasiums, and similar species are classified as instructional species when they are used directly in conjunctions with the curriculum. Okay. So, in line with the changing curriculum, especially this time that we have different strands, no? We have the STEM, the tick book, the GAS, the HUMS, and other strands of the curriculum of the secondary education or the higher, what we call this one, the senior high curriculum, no? So we have all these different types of curriculums that we had, no? So the components for home economics, industrial arts, agricultural arts, etc. in one building unit known as multi-purpose workshop building. So we call this one as multi-purpose workshop building. This is for the different strands for the senior high school. Okay, so we can use this formula for the secondary high school. We have the number of basic instructional spaces required, derived by the following formula. We have that R, okay, is equal to T times P, S times divided by S times U, no? So where your R is the required number of a type of basic instructional spaces, then it is the T is the total weekly periods for all subjects in all classes or sections and year levels required a type of basic instructional spaces. P is the usage or the used percentage, which is more or less 100% except in agricultural and fishery shops, which is only 80%. Okay, S is the weekly class periods. That type of basic instructional space is available per week, which is normally 40, but varies in schools with extended high school days. No, so U is the okay in my back. No, U is the utilization factor, which is 90% for classrooms and 85% for science laboratories and shops. Okay, so The formula is applied separately for its basic instructional space type. No? Number two, we have these administrative and service spaces. No? The administrative and service spaces are those which are to facilitate administrative administration related functions and services such as administrative offices, canteens or lunch counters, medical dental clinics, guidance room, or dormitories and other physical facilities. No? Then the non-program spaces, which is number three. Okay, non-program spaces are those which are not directly related to the implementation of the educational program and administrative functions or services such as lobbies, corridors, stairs, elevators, escalators, and so on and so forth. Those are the non-program spaces. No? The regulating space in a school building is expressed by allocating area per place or station. In instructional spaces, the area per place is the average area allocated to a pupil or student, including the furniture and equipment assigned to him or her, adequate circulation space, the space for the teacher, and integrated preparation stocks for storage space. So when we say furniture, this refers to the chairs or the table or any other physical facilities that will be very important for the student to use. No? So we have that non-program spaces. No? So likewise, the area per place in administrative and faculty offices in the average area allotted to a member of office, staff or faculty, but does not include ancillary or service spaces such as lobbies, conference room, mimeographing rooms, toilets, etc. If resources permit it, it is desirable to provide the spaces larger than the minimum. Okay, so those are the non-program spaces. Now, talking about corridors, corridors are required at ground level if appropriate direct access to enclosed spaces is provided. This is very important, especially for the student, no, for the immediate evacuation or access or exit doors or okay, so of course entrance at the same time, no. So corridors is very important. Every corridor shall not be less than 1.1 meters wide and shall be unobstructed. Now, maybe you might be observing or you might observe in your school buildings that sometimes there were chairs or tables outside or in the corridor. So that is not advisable, no? It should not be always unobstructed. Okay, above ground level, the minimum clear width is 2.0 meters, provided that the provisions of the National Building and Fire Codes of the Philippines and other relevant rules and regulations are observed. Okay, so exit doors and other alleys and corridors should be always open and available for any passerby, or passersby. Okay, so we have here letter B, the minimum standards for instructional and administrative spaces for preschools, elementary and secondary schools, and technical vocational schools, or the senior high schools. No. So these are some of the suggested minimum requirements. No. So for the classroom, it should be 1.4 square meter per place. No? Or science laboratory, 2.1 square meter per place. Or for shops, for the EPP TLE, 2.5 2.5 for girls trades or homemaking, and wood trades, metal trade, mechanical trades, electrical trades, drafting, drawing, farm mechanics, and fish capture, culture, preservation. So we have this minimum requirements, area requirements for its designated usage here per place. Okay. So the computer room or the laboratory, no? So we have this 1.4 square meter per place. The computer room laboratory is a special instructional space necessary to meet the current and future demand of modern technology. Okay, so I think in our schools you have your own computer laboratories, no? So the room shall provide at least a minimum space of 1.4 square meter per place and shall accommodate at least 10 network personal computer or PCs with other necessities and accessories such as computer tables, proper electrical wirings and outlets, air conditioning so that our equipment will not be heated or overheated, no? Two window type, preferably 1.5 horsepower air conditioning unit or 1.5 horsepower each. Okay. So windows and doors with iron grills and locks. Okay. Of course, to secure our facilities, our computer units. So number 5, you have the library or Learning Resource Center, LRC. No? So we have more or less 2.4 square meter per place. No? So the library shall have the capacity of 10% of the enrollment at 2.4 square meter per place, provided that the total area is not less than that of the standard classroom. So the standard classroom, as enumerated in previous slides, see to it that the library or the Learning Resource Center should be greater when it comes to the per unit square area, per unit area per place. No? In schools with more than one shift, the basis for computing the area is the shift with the largest enrollment. Okay, so there will be some recently or presently we know that we have some schools that accepted several shifts, no, or two shifts, one in the morning, one in the afternoon, no, and even some of the school will until night, no, early night. Okay, so we should have to consider the number of the students based on the largest enrollment, no. Okay. So we have also this library hub, no, an innovative project aimed at developing the love and habit of reading among pupils and students in public elementary and secondary schools through building warehouse libraries provided with DepEd approved supplementary reading materials or SRM. Okay, as part of its cost sharing scheme, the DepEd Central Office will provide the financing subsidy for the renovations, rehabilitations of the infrastructures to convert it as the library hub. Okay? So, supplementary readings materials will also be provided as follows. So, small divisions, medium divisions, large division, that is for the hub size. They have the suggested number of books per size of this hub, a number of copies also, and the number of titles of these books, different titles, no, number of plastic bins of this to create to provide library hubs for the need as the need arises. To attain the objectives of the project, funding for the operation and maintenance of the hubs was institutionalized through the use of the divisions called maintenance and other operating expenses or MOOA. The maintenance and other operating expenses to include the following items: library hub related in service trainings and activities, electric and water bills, and office supplies and other materials, and basic equipment necessary for the operation of the hub. Okay, site requirements for a library hub. Okay, for existing building, if we have an available building and then we just plan to renovate it to make it as a library hub, then we have these guidelines or requirements, no, preferably located near the division office. Okay, so for the DepEd, we have the different division. In our province, we have, I think, 3 division that we have. So building area is 300 square meters. That is only the minimum area, no? As the required, if we need to have to increase this, then you have to increase this one. This is just the minimum requirement of the area provided for to have this library hub. We have the minor repair or renovations, no structural defects, and road access. Okay, so those are some of the requirements to have the library hub in an existing building. So if you have new constructions, these are the requirements. Now, preferably located near the division office. Lot area is at least 400 square meters, okay, minimum. Then we have road access also. The basic features of the library hub are as follows, no? Main area with steel shelves to hold book bundles, a conference or training room, a book repair and bindery section, or check-out counters, print shops, and loading and sorting bay with steel curtain and reference filing system. So these are some of the basic features of the library hub. Okay, so sorry that I might cover it here, no? Okay, so among the basic equipments, we have the following, no? Shelving, furniture, plastic bins, and roll-away carts. Okay, at least 2 computers, barcode scanners, bindery equipment, photocopier, multimedia equipment. These are some of the basic equipment. Of course, you can buy additional equipment that you think may be necessary in the library hub. Okay, number 7, administrative and service spaces. So for the administrative office, we have the 5 square meter per place, no? For the medical dental clinic, we have 28 square meter per gross guidance room and 28 square meter gross. Okay, so these are the required space for administrative and other service spaces like medical dental and guidance room. For the preschools, we have the for the preschool education is recognized as a stage where early childhood development has long been felt, no? The present standards for preschool education consider the child, the teacher, and the school with the support of the family in maximizing the child's potential and his capacity of learning. Okay, the stimulating and meaningful experience provided in all aspects that will make him or her a socially sensitive, independent, spiritually and rational individual. Okay, the teacher is therefore expected to come up with a class program suited to the needs of the children in a particular preschool level or education. So I think maybe you will agree that it is not easy to become a teacher of these preschoolers, no? These toddlers. Okay, so you have to strengthen, you have to lengthen your patience, and the rest. You have to give your best ability, your talents to teach these toddlers in this preschool education. For pre-kindergarten or nursery, okay, so nursery is the level of education below kindergarten. The admission age for which is at least 3 years but not more than 4 year old. Okay, 4 years old. As stated in the Ministry of Education and Culture, Orders number 24, Series 1978, dated July 26, 1978, the following standards for the organization and operation of nursery classes are required. So the class size, maximum of 15 children only to a class. No? Class hours, 2 hours daily only. Physical structure, floor area, at least 7 by 9 meters in a 500 to 1,000 square meters lot. Okay? So, provide letter A, toilet and washing facilities. Okay? Adequate enough to serve the number of enrollees, which is less than 15 children only. Okay, physical structure, floor area, at least 7 by, okay, so square meters lot, no? Letter B, we have this Safety of small children must be looked into, such as wheels, digging, stairways, pools, electric installations, etc., and etc., to minimize or eliminate accidents. Okay? So, careful. So, all these hole diggings, all these wheels or stairways, no? You should have to provide uh, railings, no, for these stairways, no, and swimming pools and the rest of the electrical installations. Minimize that one, and any other hazardous facilities or hazardous equipment along the classroom of this nursery. So activity centers, listening, speaking, and acting area. We have here the reading corner, housekeeping area, aesthetic center, work area, health and cleanliness area, and playground. Those are the activity centers that we should have to provide for the kindergarten only, you know. So, letter B, school site. So, the Department of Education, Culture and Sports Order 107, series of 1989, stated that the standards for the organization and operation of preschools or kindergarten level, so these are minimum of 500 square meters, no, for not more than 4 classes. So classroom 140 square meter minimum, playground 360 square meter. So these are the suggested minimum area necessary when it comes to lot area, no. So alternative space for playground, nearest park or open space not more than 200 meters from the walking distance from the school. Okay? So maybe there might be some public places, but or public playground, but you should have to consider the distance from your school. These arrangements must be approved in writing by the authorized representatives of the park or open space. Okay, to keep our children safe. Number two, school site must be used for educational purposes only. Must not serve as residence of the owner and should not be a convertible school. Okay, so during daytime is used as school and after class hours is a residence or used for commercial purposes. So see to it that our building should not be something like this, no? So to emphasize, this school should not be used for residence of the owner or any other personnels, and of course it should not be convertible to other purpose, but simply for the academic instructions only. So provision for office, teachers room, music and library room or rooms combining any two of these must be considered. Okay, so some of the rooms will be used for offices and may be used as music or library rooms, but you should have to consider the strict regulations, guidelines to use that room. Classroom size should be 1.5 square meters per child or okay, per place. No? So when it comes to equipment, playground and garden, okay, playground apparatuses must be installed in the school ground. Jungle gym, sandbox, slide, balance beam, simple obstacles, tires, and tunnels. So these are some of the suggested facilities in the playground. Letter B, classroom equipment and fixtures. Furniture, tables, chairs, shelves, lockers, and others type of these furnitures. Okay, so conform the standards based on the anthropometric measurement of preschools age children both in standing and sitting positions. Okay, so this is very important, no? The anthropometric conformity of the these furnitures for the use of the children. Take note that they are very young and maybe they have still a soft bone. Okay, so might be easily injured. So see to it that our furnitures should be or must conform the standard. Okay, so beds and or mats may be provided for rest periods. No, so it is understood that sometimes our children got easily weak or lost their maybe little, of course, endurance. So they might rest. So during rest periods, then we must have to provide beds and or mats for them to rest or to sleep. No. Okay. Letter D, health facilities and provisions for safety. At least one toilet set for every 25 children at one time, preferably with separate bathroom for boys and girls. Then the facilities, health facilities may include first aid kits must be available. So rest area may be provided for children, and then proper and adequate lighting and ventilation. There should be natural and electric lighting. Okay, so a combination of natural and electric lightings now. For a 7 by 9 classroom, at least two 40-watt fluorescent lamps and one wide window for this kind of rooms. Okay, letter E, activity centers or areas which may contain the following or their equivalent. We have here the personal care and grooming, okay, which may include mirror, comb, towel, toothbrush, soap, toiletries, and others. These activity centers also composed of a house and a garden care. Okay, so provides house and garden care. Garden tools like shovel, spade, pails, sprinklers, sand table, cleaning tools, and etc. And also communication skills corner. We have the books, no? 2 books per child. Story books, science, or nature books, or Filipiniana. We must have to provide. Okay. So we have also the sensory perceptual and numeracy skills corner. So we have here the science and mathematics corner that provides counters, beads, number of cards, nature tables, and etc. to exercise their sensory and perceptual and numeracy skills of the children or the child. Okay, letter F, motor and creative development corner. Percussion instruments, bamboo castanets, coconut maracas, no, or tambourine, tape recorder, or phonograph. Okay, provide for this motor and creative development corner. DepEd orders number 93 series of 2009. September 10 specific date, no, September 10, 2009. Preschool building program. This prescribes the classroom and furniture design for preschool, including floor plan and furniture designed. Okay. Number 9, strengthen technical vocational schools. This is one of the strand of the senior high schools. No, one of the department's goals is to equip the high school students with relevant skills through the Strengthening Technical Vocational Education Program or STBEF EP in order to prepare them for higher education, world of work, and for entrepreneurships. No, so tickbook is highly required. No, so that our facilities for this tickbook strand for this senior high, because this is in preparation of the pupils or the students to work after high school, no, and if they cannot pursue their college education. The tickbook high schools shall be strengthened by providing a competency-based curriculum and training, physical facilities, instructional materials, manpower requirement, and other logistic supports. So these are some of the important requirements when it comes to when it comes to tickbook for the senior high school. Among the 9 programs components of STVEP is infrastructure support. Okay, so the department prioritized the possible infrastructure requirements of tickbook schools starting 2008 to 2009. So we have these different priorities of the DepEd, no, to support this textbook education. So priority 1, repair and rehabilitation works of existing laboratory workshop buildings, okay, of all 140 textbook schools. Most ready to implement STBEP in school year 2008 and 2009. Priority 2, construction of workshop buildings, and priority 3, repair of workshop buildings in 129 textbook schools ready to implement the program last 2008 to 2009. Class size in textbook schools are 40 students for the academic subject and 30 students for the specialized STVEP. The minimum standard spaces are as follows. So we have here shops, workshops, a laboratory for textbook. No, so just go over with this one. So we have this letter C, the design of school buildings. Now let us continue on our design guidelines. So we have these different types or general guidelines to build the school buildings. Letter A is school building. Okay, so a school building shall be designed in accordance with its function and needs of its user and the nature of the environment. Letter B, in view of scarce resources, school buildings shall be conceived for economy and in construction, utilization, and maintenance. So anyway, there are several ways on how you're going to finish the project or implement the project by minimizing the what we call the financial needs, no, or just construct the building phase by phase, no. The design approach shall be straightforward, relying upon simplicity of concept in the context of innovation to reflect order and dignity, ensure flexibility and anticipation of educational change, and achieve structural ability. Okay, the following general guidelines, we have additional general guidelines. Letter D, human dimension, static and dynamic specifically, with reference to Filipino children and youth, shall be the basis for establishing scale. So letter D, we have the aesthetic element shall be integral to the overall design, and even given contemporary treatment shall derive from historical, traditional, or native themes. Okay, so we have this letter F. We have here the use of indigenous or locally produced materials shall be maximized in conjunction with the application of appropriate construction technology. So as much as possible, try to use this indigenous material so that it might be applicable to minimize, to lessen the expenses of building the school, no? So we have letter G, provision for mobility of handicapped, disabled provision or disabled person shall be given due considerations in the design and construction of school buildings, no, and other facilities in accordance with Batas Pambansa Bilang 344, the accessibility law. So in all buildings that you have, or if you plan to create a building to build a school, then try to consider those PWDs, no, persons with disability, no, physical disability. So in designing school buildings, consideration of ergonomics, anthropometrics, thermal comfort, illumination, acoustic, and colors, as mentioned in Unit 1 or Chapter 1 in this book or reference. Number 2, placement and layout. A school building shall be properly oriented, properly placed with regard to air currents, natural light and heat from the sun, utility of the plant and grounds, and most advantageous display. No, it is directly related to the health and comfort of the pupils or students and teachers, hence the efficiency of the school plant. Okay, so that is very important. Anyway, in the previous unit, we discussed the placement of our building, the orientation of our building according to east-west orientation and other placement of our building. Okay, school building orientations. Okay, so it might be mentioned here again, no? Orientation of school buildings located in coastal areas should be considered. The direction of possible storm surge. Okay, so we experienced several times during typhoons, heavy typhoons, no? That the sick produce this what we call as resulted to storm surge, no? So consider the orientation of the school buildings against this storm surge, possible storm surge. Impact of storm surge will be less if the shorter side of the building faces the coast instead than its front, no? According to Engineer Rodel Veneracion Plan Philippines, no? The proper orientation of school buildings aims primarily to minimize direct sunlight inside the classroom and to maximize the entrance of breeze or air currents into them. Okay, so the solar paths of the sun or the sun path, no? Prevailing winds are the two major factors to be considered in the orientation of the school buildings. Okay, so we have here the solar or sun paths as I mentioned. This refers to the direction of the sunlight as the earth rotates on its axis, which is usually from east to west, no? With some light variation during certain seasons of the year, which may be regarded as negligible. So we have to consider this one in this figure 1, building properly oriented along solar path. This is the east-west direction. Okay, so prevailing winds, breezes refer to the direction in which the cooling breeze blow. In the Philippines, especially during the hot season, prevailing breezes generally have a northeast to southwest direction. So just try to consider if you're going to orient your building. Taking into consideration the two factors, the recommendable orientation of the school building in the Philippines is a northeast-west to southeast-east axial direction, no? Special instances where the path of typhoons occur east to west directions. Of course, the onset of the southeast-northeast monsoon, amihan habagat wind shall also be considered. This is especially if our school or our building will be built near in the ocean or the sea. Okay, so the layout of school building on the school site refers to the location and arrangement of school buildings to achieve maximum functional efficiency and aesthetic effect. Okay, so we have here as a general rule, the different school buildings shall be laid out according to functional groupings. Okay, we will discuss that later. So the distances between school buildings shall be such that letter A, ventilation is not obstructed. That is very important to give comfort to our students or our children. No? Natural illumination is not impeded. What is the source of the natural illumination? So of course the sun and the light from the sun. No? Then sound in one building do not carry into the next building. So consider that one. The suggested minimum distances between the building. Okay. So we have 8 meters between one-story buildings positioned side by side. 10 meters between the two-story academic buildings positioned side by side. Then 10 meters between non-academic buildings. For a main building facing the front gate, at least 10 meters distance is suggested. Okay, so the minimum distance between, D5, greater distances than the minimum between school building is desired. Wider distance between buildings allows for adequate free space to be utilized for many school-related activities. Okay, so letter E, the recommended minimum setbacks of a school from the street is 5 meters to minimize intrusive sounds. the acoustic barriers. No, we should have to implement the acoustic barriers in a way. Later on, we will discuss that. The school site development plan must be considered in the laying out of the school building. So, building plans, number 5. There are two types of plans for the design and specifications of public elementary and secondary school buildings. We have for letter A, standard building plan. This is usually prepared by the architect and engineers for the DepEd and the DPWH, kay the Department of Public Works and Highways, no? Approved for general use in all schools throughout the country. A special building plan. This is a plan designed specifically for the particular school for a special purpose or because of a certain unique or peculiar features of that school site. Okay, so we should have to create to produce a special type of building plan. So a special building plan may originate from the field. So we have this school building plan originating from the field. Local government units and private entities shall be submitted to the PFCID, OPS, or DepEd for review and approval. No? So the plan shall be drawn in tracing paper measuring 0.5 by 0.75 meters or 500 by 750 millimeters, no? According to an appropriate scale, and shall now show the following. Okay, so our plan should be or shall be drawn to scale, that which includes the following: perspective and site plan, floor plan, front, rear, right, and left elevation, two sections, foundation plan, floor framing, and others. Now, this is for if it is elevated. And we have also the roof framing plan, ceiling plan, and electrical layout, plumbing layout, and other details. Okay? So, letter B, the original copy of the plan on a tracing paper together with the two sets of white print or blueprint shall be submitted. The architectural and structural plan shall be signed by the architect and civil engineers respectively, duly stamped with their dry seals along their registry numbers and professional tax receipts or PTR and tax identification numbers or TIN. Letter D, the structural computation signed by a registered civil engineers or an architect structural engineers and stamped with his dry or her dry seal shall be submitted together with the plan for checking. The registry number, professional tax number, PTR, and tax identification number, TIN, of the civil engineer shall be also indicated. Okay, the plan shall be signed also by the school administrator concerned and recommended by the school division superintendent and the DepEd regional director. Okay, so these are some of the important requirements to have this building plan. Okay, design requirements. Of course, the following pertinent requirements prescribed in National Building Code or the Architectural Building Code of the Philippines shall be considered. Windows, no? Window opening shall be equal to or at least 10% of the floor area of the room, provided that such opening shall be not less than the 1 square meter, except those in the toilets and baths, which shall be not less than 1/20th of the floor area of such rooms. Okay? So, or not less than 240 square millimeters. Still, casement for windows using plain GI sheets can be used to resist strong wind from entering inside the building that creates an uplift force that blow up roofs. Okay? So, we have also here the ceiling heights, no? So, it is emphasized here the ceiling heights shall be not less than 2.7 meters measured from the floor to the ceiling. So, for the floor construction, all floors shall be framed and secured into the framework, supporting walls so as to form an integral part of the whole building. The type of floor construction used shall provide means to keep the beam and girders from the lateral buckling. So the beams is used for the horizontal support of any part of the building, and the girders are from the other support structures of the building. Rope constructions, all ropes shall be framed and tied into the framework and supporting walls so as to form an integral part of the whole building. Dark stops, roof drains, flashing, etc. shall be provided. Purlins can be made up of angle bars instead of the conventional C-purlins, no? Where thick screws easily loosened, resulting in detachment of the ropes. Okay, that is one of the problem in using that C-purlins, because the thick screws can be easily detached or loosened up, no? Okay, so exit doors are also necessary. At least 2 exit doors are required, where the number of rooms occupants in every 50 in the case of classrooms and others, no? So the doors shall not be less than 2.1 meters high and 900 millimeters wide. So that is for the exit doors. Doors shutters, no, shall be swing and out and be capable of opening at least 90 degrees so that the clear width of the exit is not less than 700 millimeters. Corridors, every corridor shall not be less than 1.1 meters wide and shall be unobstructed, as we mentioned a while ago. Stairways, okay, so stairways serving the occupant load of 50 or less must be 1.1 meter wide. Those serving more than 50 students shall not be less than 1.5 meters. The rise of every step shall not exceed 200 millimeters, and that tread shall not be less than 250 millimeters. This is handicaps or handrails shall be provided on each side of every stairway having more than 4 steps. So let's continue with this building rest reduction requirement. So this is very important, no? We should have to consider the safety of our students, not only the students, the faculty, and the staff or personnel of our school. Okay, in designing and constructing school buildings, safety and risk reduction measures shall always be considered. Now, of course, if you cannot eliminate risk, then better try to think of the reduction of this risk, no? Detailed engineering shall proceed only on the basis of the feasibility or preliminary engineering study made which establishes the technical viability of the project and conformity to land use and zoning guidelines prescribed by the existing laws. Okay. So, scheduled detailed engineering activities shall include the following: the survey, site investigation, foundation investigation, soil and materials investigation or testing, preparation of the design, preparation of the specifications that conforms the design, preparation of quantity and cost estimates, the quantity, bill of quantities, and the cost, the estimated cost of the plan and the planned construction, and the preparation of the program of works or POW, no? The BOQ, the bill of quantities, and the program of works, the POW. Preparation of proposed construction schedule and estimated cash flow for projects with schedule over 6 months. Okay. Preparation of site or right-of-way plans, including schedule of acquisition. So that is very important. Accessibility is also important. The acquisition of the building or the land area, preparation of utility relocation plan. If you need to have to relocate anybody, or even the structures, if you're going to relocate structures, then you have to plan of it, no? Preparation and submission of design report, environmental impact, okay, approval of the ECC and the statement for major projects, preparation of bid or tender documents. Okay. So we have number one. We have the important one of the important thing that you're going to do is risk reduction requirements. As we said, if we cannot eliminate, then try to minimize or reduce, no, for parts of a school building and amenities. Talking about main entrance or gate, a main entrance shall be located preferably in a secondary road and must be designed swing in to the school property. So, preferably in the secondary road, not in the primary road, because it might have a busy mga vehicles, no? Or traffics, no? Busy traffics. Then, provide separate service entrance for the pupils, students, and guests. Okay, provide this main entrance shall provide enough clearance for fire trucks and medical vehicles in case of emergency. So for the electrical fixtures, require protective covering for all wirings and fixtures. Install a fire alarm system, but it is affordable. That is affordable. Provide environment-friendly fire extinguishers and any other fire hydrants and fire suppressant. No? Report any defective electrical wiring and fixtures to experts and to electricians and electrical engineers as may be required. No? Hang curtains in the classrooms away from the wall-mounted fans. Otherwise, it will be damaged or it will damage the electric fan. No? For stairs and handrails, so distance between railings shall not be more than 100 millimeter or 4 inches so that pupils and students cannot squeeze through by these railings. No? For abrupt change in floor elevation, provide ramp to avoid freak accidents. Okay? Then, to minimize the chance of slipping, slip or sliding, avoid smooth or polished steps, surfaces, and provide non-slip nosing. Always provide landing with railings between a doorway and a stairway. So you must have to provide landings, no? So for a few steps in a stairway, then provide landings, no? Then when it comes to windows, okay, windows shall be provided with the security grills with emergency exit, of course. Otherwise, maybe they will jump in the window. Then if it is two-story, then it might results to injury of our student or okay, so our student or our children. Doors and or exits classrooms shall always be provided with 2 swing out doors at the opposite side of the classroom. Okay, for when it comes to walls shall be smooth finished, no? Smooth finished to prevent injury to highly active, playful and mobile primary grades pupils. Okay. So let's talk about hazard resilient approaches. The geographic location of a wide variety of natural phenomena such as typhoons, cyclones, floods, earthquakes, and other beyond our control, human control. Okay, so we have to think about resilient approaches. The occurrences of these hazards are the main causes of building deterioration and damages, which is taking part of the department's budget. Okay, so talking about budget allocation for the repair and rehabilitation of damaged structures and educational facilities could have been used in the construction of the new buildings. If you can minimize damages or slow down expenses on rehabilitation or repairs, then better to save it to have a new construction of the new school buildings. Okay, in view of these initiatives that will reduce the impact of these hazards, which will eventually become disasters when not properly addressed. Okay, so are being undertaken through the hazard mitigation planning and comprehensive disaster risk reduction. As defined in an interagency network for education on emergencies guidelines or INEE, okay, mitigation refers to the measures that can reduce or eliminate the vulnerability of the built environment to hazards, whether natural or man-made. Okay, the fundamental goal of mitigation is to minimize loss of life, minimize property loss, and function due to disasters. The designing to resist any hazards should always begin with a comprehensive risk assessments. No? So that is very important. This process includes identification of the hazards present in the location, and an assessment of their potential impacts and effects of the built environment based on existing or anticipated vulnerabilities and potential loss of property, life, and any other valuable things. There are many terms referring to the components of risk assessment. One of which is terrorism, which are referred to as threats by the armed forces of the Philippines, while floods, earthquakes, typhoons, and volcanic eruptions are being referred to as by hazards, as hazards by emergency managers. No? In simple terms, both of these are are forces that have the potential to cause damages of the things and properties, and or even death of human death and injury and loss of functions and education sector. There are many terms referring to the components of risk assessment. One of it is terrorism, which are referred to as threats, no? And the others, no, hazard. Simple terms, both these are forces that may results to that damage, death, injury, and others. Okay, so we have principles involving this process, which includes the impact of natural hazards and the cost of the disasters. The cost will be reduced with their mitigation measures are implemented during the pre-disasters. Risk reduction also techniques must address as many applicable hazards as possible. Okay? So, mitigation of existing facilities. Mitigation is based on localized, designed criteria and established established facility renovation mitigation for multiple requirements. For example, seismic and force protection are most effective when addressed simultaneously. Professional and experts agree that the most successful way to mitigate losses of life, property, and function is to design buildings that are the disaster resistant. No? We have this INEE guidelines proposed that this approach should be incorporated into the project planning, design, and development at the earliest possible stage, so that design and material decisions can be based on the integrated whole building approach. Okay, so all this risk reduction plan or activity should be implemented as the project or the planning period of the project started. Okay, so multi-hazard guidelines. So, what are some of these multi-hazard guidelines? Talking about event, no? First, talking about earthquakes. Okay, so building design will be influenced by the level of seismic resistance desired. This can range from the prevention of non-structural damage and frequent minor ground shaking for prevention of structural damage and minimize of non-structural damage and occasional moderate ground shaking and even avoidance of collapse or serious damage and rare major ground shaking. So these performance objectives can be accomplished through a variety of measures such as structural component like shear walls, breast frames, moment resisting frames, and diaphragm based on isolation energy dissipating device such as viscoelastic dampers, elastometric dampers, and so on and so forth. For the tropical cyclones and tornadoes, no, the key strategy to protecting a building from high winds caused by tornadoes, hurricanes, and gust fronts is to maintain the integrity of the building envelope, okay, including roofs and windows, and to design the structure to withstand the expected lateral and uplift forces. For example, roof trusses and gables must be braced. Hurricane straps must be used to strengthen the connection between the roof and the walls. And doors and windows must be protected by covering and or by bracing. Okay. So school buildings in the Philippines are highly susceptible to typhoon-induced damage due to the use of light materials. No, that is the sad reality. No, non-structured elements should be properly and adequately anchored, connected to the structural members to avoid uplift or toppling down during the strong winds. Design of this school building should consider the topography of the site, exposure of the buildings, and wind velocity or a wind zone map. School buildings foundations should rest on the stable grounds to provide adequate resistance against overturning or damage. Okay, talking about flooding. Flood mitigation is best achievement by hazard avoidance. That is proper site selection away from. So flood plains, okay, flood plains. No, should building be sited in flood-prone location, they should be elevated above the expected flood levels to reduce the chance of flooding and to limit the potential damage to the building and its contents when it is flooded. Flood mitigation techniques include elevating the building so that making the building so that the lowest floor is above the flood level, dry flood proofing, or making the building watertight to prevent water entry. So wet flood proofing or making uninhabited or non-critical parts of the building resistant to water damage, relocation of the building, and the incorporation of levees and flood walls into site design to keep water away from the building. Okay, talking about rainfall and wind-driven rain, one of the primary performance requirements for any building is that it should keep the interior space dry. Okay, all roofs and walls must therefore shade rainwater, and design requirements are the same everywhere in this respect. For example, roof drainage design must minimize the possibility of ponding water, and existing buildings with flat roofs must be inspected to determine compliance with this requirement. Okay, so letter A, differential settlement or subsidence. No? Okay, ground subsidence can result from mining, sinkholes, underground fluid withdrawals, compaction, and organic soil drainage and oxidation. Okay, so this is subsidence or differential settlement. Subsidence mitigation can best be achieved through careful site selection, including geotechnical study of the site or investigation or testing. In subsidence-prone areas, foundations must be appropriately constructed, basements and other below-ground projections must be minimized, and utility lines and connections must be stress-resistant. Okay, so when retrofitting structures to be more subsidence-resistant, shear walls, geofabrics, and earth reinforcement techniques such as dynamic compaction can be used to increase resistance to subsidence damage and to stabilize collapsible soils. Okay, so we have here Landslides. Okay, talking about landslides. Okay, gravity-driven movement of Earth's material can result from water saturation, slope modifications, and earthquakes. Techniques for reducing landslides and mudslides race to structures. Okay, include selection on an hillside. Okay, constructing channels and other water drainage, no, and planning ground cover. Okay, sorry, planting ground cover, and soil reinforcement using geosynthetic materials and avoiding cut and fill building sites. Okay, so talking about tsunami, especially for those buildings or schools nearer to the sea or the ocean, no? So, um, tsunami is a series of ocean waves, no? Generated by sudden displacement in the sea floor or landslides or volcanic activity in the seashore or in the mainland, no? In the deep ocean, the tsunami wave may also be a few inches high. Okay, the tsunami wave may come gently ashore or may increase in height to become a fast-moving wall of turbulent water several meters high. Although tsunami cannot be prevented, the impact of tsunami can be mitigated through urban or land planning, community preparedness, timely warnings, and effective responses. Okay? So, that is about the minimizing or reducing the risks. Now, we have number 3 here, emerging issues and concerns. Okay, letter A, hazard mitigation and sustainability. Okay, so unsustainable development is one of the major factors in the rising cost of natural disasters. Okay, so if you cannot sustain all these development issues or activity against these emergency hazards, no? Given that hazard mitigation is at the core of disaster resistance, many design strategies and technologies serve double duty by not only preventing losses but serving the higher goal of long-term community sustainability. Okay, cost of mitigation measures and retrofits. Okay, the cost of incorporating multi-hazard mitigation measure in existing buildings is an issue of increased importance because as a critical mass of facilities were built before multi-hazard construction measures were incorporated in modern building codes. Initially, building codes were developed solely to prevent or reduce the loss of life and property due to fire in buildings. Okay, so we have these relevant codes and standards. Okay, regulation codes, standards, and best practices will guide the design of buildings to resist natural hazards. For new buildings, code requirements serve to define the minimum mitigation requirements, but compliance with the regulation and building design is not sufficient to guarantee that a facility will perform adequately when impacted by the forces which is for which it was designed. Indeed, individual evaluation of the costs and benefits of specific hazard mitigation alternatives can lead to effective strategies that will exceed the minimum requirements. Okay? So, additionally, special mitigation requirements may be imposed on projects in response to local specific hazards. When a change in use or occupancy occurs, the designer must determine whether this change triggers other mitigation requirements and must understand how to evaluate alternatives for meeting these requirements. Okay? So, condemned unfinished construction. If we have this unfinished building or condemned building structures, ongoing construction must be cordoned with an off-limit sign. Okay, that is very important. We have this precautionary activity. So try to caution tape, no? So establish a caution tape to warn the students, the pupils, not to go inside or not to get nearer with that building, unfinished building or ongoing construction building. So sanitary facilities, drainage canal shall be wide enough, covered and provide with manhole for safety and sanitation also. The location of the septic tank must be at least 2 meters away from the building. Okay? It shall be properly vented for proper release of gases. It must be at least 25 meters away from any source of water supply to avoid contamination. So those are the requirement if we have this water supply. Okay, so we have this number 4, understanding structural issues. Structural failures are common and considered costly to rectify. Talking about our building, no, the structural strength of our building. Most structural problem may be avoided by proper design and planning. Structural issues focus more on the concrete structure failures, since concrete is the most commonly used in a building construction due to its durability and ease in the construction. Of course, it's very hard this time to find woods because cutting trees is now prohibited. The objectives of the understanding structural issues and problems are first here, to recognize common structural problems and their causes, to know the immediate solution of structural problems before the recommendation of the structural engineer has been given consideration, to know how to mitigate or eliminate the structural problems. Okay, so we have these main structural elements of buildings. Okay, so I hope that you can see these structures here. The main elements of the structure are the load-bearing members. Okay, so in civil works, civil engineering works, then we will know, they should know what are those load-bearing members or part of the building. They support and transfer the loads on the structure while remaining equivalent to each other. The places where members are connected to other members are called joints. Okay, so we have several parts of the construction of the building or the building itself. So we have these members, as they mentioned, that every members are joined together. So it is called joints. No? Now, common structural problems, failures, and causes. Recognizing the symptoms of structural movement and displacement is the key to understanding the extent of the concern. This section will give some of the common indicators of structural concern, and these cases, a structural engineer should be called out to investigate further and provide professional opinion. Understanding and recognizing failures mechanisms in concrete is a fundamental prerequisite to determining the type of repair, no? Or whether repair is feasible or not. Okay, so talking about concrete preparation and maintenance problem. Okay, creasing is a pattern of the fine cracks that do not penetrate much below the surface and are usually a cosmetic problem only. They are barely visible except when the concrete is drying after the surface has been wet. Okay? So, plastic shrinkage cracking. Okay, when water evaporates much faster from the surface of freshly placed concrete than it is placed by the bleed water, since the concrete surface shrinks. So, these are some of the concrete problems now that you might encounter during construction. Okay, so drying the shrinkage, because almost all concrete is mixed with more water than is needed to hydrate the cement. Much of the remaining water evaporates, causing the concrete to shrink. Okay, so that sometimes because it is understood that in mixing concrete or mixing cement with pebbles, with sand, and the rest of the component, water also, the amount of the water also is usually considered. But of course, that during the pouring of this concrete mixed, the mixture has been dried up. So some of the contractors or the mason will try to add water, and much water inside or within the mixture, the cement mixture or the concrete mixture might results to shrinking when this water evaporates, no. Then we have also these thermal cracks, no. Thermal cracks or temperature rise results from the heat of the hydration of the cementations materials, no. So as it will become dried, then there will be a high temperature, or the temperature will rise. Then it might resulted to cracks. No, as the interior concrete increases in temperature and expands, the surface concrete may be cooling and contracting. So that is why most of the time what the contractor did is that they will they will pour water or sprinkle water so that it might reduce the temperature. Now another problem, no, corrosion. Okay, corrosion of reinforcing steel and other embedded metals is one of the leading cause of deterioration of concrete. Okay, so your materials, your metal reinforcement steel might be corroded, and it might reduce its physical strength, and that it will reduce also the strength also of the concrete. When steel corrodes, the resulting rust occupies a greater volume than steel. Okay, so it will resulting to, or it will result to cracks. Okay, so the expansion creates tensile stresses in the concrete, which can eventually cause cracking and spalling. Okay, so performance problems of structural concrete. So concrete foundation. This foundation settlement cracking may be caused by differential settlement of the footings for original construction, water nearby, blasting operations, or improper soil preparation, so on and so forth. Punching failure are failures caused by excessive concentrated loads or point loads, no? Okay, wide beams shear failure may be due to improper use of material and or inadequate foundation thickness and any other reinforcement rebars, no. So bending failure due to improper use of material, inadequate foundation thickness, and or inadequate reinforcing bars. So the reinforced the rebars might not be, the design and specification might not be followed. Okay. Fancing failure are failures due to excessive concentrated loads or point loads, improper use of material, and or inadequate slab thickness. Okay, so might we be able to lessen the thickness of the slab, or that sometimes more than what it is specified in design. Okay, it will affect the concrete slab. Okay, or the thickness, or the thickness of the slab might affect the strength of that slab. Settlement cracks in a slab indicate inadequate site preparation. Okay, such as failure to compact fill on which a slab was poured. So that is why the contractor or the construction must use this vibrator, no, so that the concrete slabs will be totally or evenly filled up, no. So they use these vibrators in pouring. So we have also this suspended slab, no? Bending failure due to improper use of material, inadequate slab thickness, and or inadequate reinforcing rebars. Okay, so punching failures are due to excessive concentrated loads or point loads. Bending failures also is due to improper use of materials, inadequate beam size, and or inadequate main reinforcing bars. Shear failure due to improper use of material or inadequate beam size and or the stirrups. Columns. Talking about columns here, bending failure due to improper use of material or inadequate column size and or main reinforcing bars, no? Or axial failure due to improper use of materials or inadequate beam size. So that is, it should always be remembered that these columns is more or less that is similar to uh, skeleton, no, that supports our body. So whatever the design of that column should always be strictly followed. That is very important. Okay, so let's proceed to structural steel. Okay, failure due to environment exposure, failure due to heat. Heat changes the steel characteristic, which leads to deterioration of strength. So it is very clear, no, that if we are going to let this steel be exposed to uh, excessive heat by the sun or any other source of heat, then the strength of this steel will deteriorate or it will weaken. Okay, corrosion steel corrodes on contact with water, acids, base, salts, oils, aggressive, no, metal polishes, and other solid and liquid chemicals. Performance problem of structural steel, okay, are bending failure, shear failure, and buckling failure. Number 5, immediate remedial measures. Okay, so if the building shows signs of structural failure, the following should be undertaken until further instruction from the structural engineer has been given. If you will find problems and if you can observe any performance of the design, no, or the construction as it is undertaken, then try to call the attention of the structural engineers. But before that, the most advisable thing to do is do not occupy the building. Okay, project engineers should initiate the material testing on compressive strength of the concrete, yield strength of the steel. Okay, so that is very important, no? That you have to test the compressive strength of the concrete and the connection as between the end of this steel, the yield strength of the steel, no? So try to check and try to evaluate the strength, or try to test the strength of the material. Immediately, the structural engineer should be called on to investigate further, and the project engineer has to submit to report the structural engineer that includes the following: background information of the building, location, description, what it is composed of, either concrete or steel, year constructed, project implementer. So try to orient the structural engineers so that he or she may be able to find solutions of the observed problem. Plan dimension of building showing the members, member sizes and dimension, and location of failures of the members. Cracks, sagging, the sagging of the beams, okay, crash, buckling, settlement, etc. Okay, pictures of failures, no? So situate that every time you must have to take pictures for an evidence and for the comparison for any movement or differences in the actual or the present and the previous position or situation. Geotechnical report where the soil bearing capacity is shown. result of the material testings. So try to show and share this to the structural engineers. So provide shearing in the horizontal members and inject structural epoxy on concrete cracks to be applied by the professionals. Okay, number 6, building failure mitigation. How to mitigate, to minimize these building failures. So, most structural failures are due to failure to comply to the requirements shown in the structural plans and specifications. Members, sizes, reinforcements, material specifications, soil preparations, and construction methodology. So, this might be some of the causes of the building failures. No? Having good quality construction is the best way to prevent any structural failures. Okay? The following shall be the basis implementing construction to mitigate structural failures. This must also be the basis on in accepting and rejecting works. Okay, so anyway, later on we will know that after the constructions we should have to give certification or certificates to the contractor. Now, if the performance of this contractor is not good or it is poor, having a poor performance, then of course we should have to think or whether or not to accept the finished building. The most updated and official plans and specifications must be used. Make sure that these documents have structural engineer signature and seal. Okay, so try to produce or require the contractor of having this as-built plan or the revised plan as what they applied in the construction proper, no? Then conform with the specification and required structural standards and construction notes. Okay, ensure that the required member size and material strength will be used. Only the accepted standard methodology will be implemented, or otherwise, because whether we like it or not, in the actual construction, some of the foreman or even the construction engineers will change and find their own way to implement the project that sometimes might result to an adequate strength. Should there be any failure in the material strength and or any structural problems encountered during the construction, immediate remedial measure must be carried out. Okay, so that is one of the important thing. That is why it is suggested that from time to time there will be having a joint meeting or coordination meeting with the project implementing unit and the inspectors and of course the contractor. Okay, so that few problems, small problem might be addressed immediately so that it will not become a bigger problem later. In conclusion, various types of problems with regards to structure can create dangerous or costly situations. So if you can repair, if you can make a remedy as early as possible, then it might minimize further costs in the change or renovations or rework of the construction activity. To immediately discover and evaluate structural defects, we should know the major impact of this on safety. One does not have to be a structural engineer to be able to identify where structural problems are likely to occur and how to recognize them. So we are not, or maybe many of us are not structural engineers, or we are not structural engineers. But of course, but through our observations, we can give ideas and hints to the engineers to study more and investigate more about the performance of the construction. Okay? So, miscellaneous requirements, that is number 7. In the construction of buildings under plans and specifications prepared by the Department of Public Works and Highways and approved by the consulting architect, no change affecting neither architectural features nor substitution of materials shall be made without the approval of the consulting architect or the structural engineers or the civil engineers and of course with the coordination with other programs or professions like electrical engineers, the what you call this one, the mechanical engineers, and even computer engineers, no? So under no circumstance shall any plan, whether prepared by the Department of Public Works and Highways or not, be used for any project other than the one originally intended without first securing a written approval of the consulting architects. Okay? So let's proceed to acquisition of new school buildings. So what are the considerations and acquisition to the new school buildings? New school buildings are usually acquired through allocation from the national government by donations and from voluntary contributions. Under the national government school building program funds are provided in the national budget every year for the construction of the new school buildings. We have this criteria, no? So to replace school buildings destroyed by natural calamities and fortuitous events. Okay, so beyond the commerce of man, uncontrollable emergencies, no, or calamities, to replace old and dilapidated school buildings which have been condemned, to provide new school buildings to school with high shortages. Okay, so to accommodate the increase in school population or to decongest existing ones, to replace makeshift and temporary school buildings. And last one is to provide school buildings to accommodate classes currently housed in rented buildings, school stage, gymnasiums, and other existing facilities. So, number one, allocation procedure for new school buildings. The Congress, in conjunction with the Department of Budget and Management or DBM, set the budgetary ceiling for school building projects. Department of Budget and Management advises DepEd and DPWH Central Office of the approval of the annual school building program. DepEd Central Office issued a department order to all regional directors and school division superintendents containing the guidelines and preparing the priority list of recipient schools based on the prepared allocation per legislative district. Okay, so DepEd regional offices advise division offices to prepare priority list using the department order. Letter A, DepEd division office ad hoc physical facility unit headed by the physical facility coordinators prepares priority list in coordination with the planning unit. Okay, so this PFC seeks concurrence of congressional representatives concerned of prepared list. DepEd Division Office submits list to DepEd Control Office, Central Office, Physical Facilities and School Engineering Division or PFCID. Copy furnished the regional office. Letter G, DepEd PFCID consolidates division list and forwards list to DBM through DPWH Central Office to the case of the regular school building program or SBP. DBM evaluates list, issues special allotment release or order or SARO and the corresponding notice of cash allocations or NCA of the approved projects. DPWH and DepEd implement projects listing in the annual school building program. Okay, so talking about pre-construction, no? So, talking about pre-construction activity, following conditions must be met. The school site in which the building is to be erected is titled and registered in the name of DepEd. So, that is one of the requirement that before the construction will be done, then there should be a compliant of presenting the legal title in the name of DepEd. Land title in the name of the DepEd. In case the property is registered in the name of a municipality or city, DepEd shall acquire a perpetual right of use through a gratuitous contract of lease with the municipality or memorandum of agreement defining a clear terms, the conditions relative to its use, the control and supervision of the school site, particularly the ownership of the building or facility so constructed. The contract of lease must be registered with the Register of Deeds and duly annotated as a memorandum on the certificate of land title. If the proposed school site is presently used for school site purposes without any adverse party claimant, appropriate steps to ascertain the probable basis of DepEd's title or right to possess shall first be taken before any other construction is undertaken. The results of the verification together with the complete records regarding the site shall be forwarded to the office of the Undersecretary for Legal Affairs in the Central Office for appropriate legal attention and action. Okay. So, letter C. If the proposed site is privately owned, the appropriate documentation attesting to any eventuate right of DepEd on the proposed site shall be firmly established. And until the available transfer documents are available, no construction shall be initiated until clearance is first secured from the office of the Undersecretary of Legal Affairs. For this purpose, the pertinent transfer documents, if any, including proofs of ownership, shall be forwarded together with the request for clearance, and any transfer document shall at least bear proof of registration and appropriate memorandum thereof, which is annotated on the back of the certificate of that land title. So those are things which are very important, no? And the construction that basically we will not start our construction without these legal papers or documents to support the ownership of the land, no? So letter D, in case the private proposed in case where the proposed site has been acquired by DepEd through sale, but the transfer title is in favor of the DepEd has not been issued, the deed of absolute sale evidencing proving the sale shall be registered and the appropriate memorandum thereof is annotated in the back of the certificate of title. Okay, if there is no such transfer has been done, the construction will commence if we have this deed of sale, no, as a proof, deed of absolute sale as a proof of the ownership by this DepEd. If the reason for non-transfer is due to lack of subdivision plan segregating the conveyed area from the main portion of the property, steps to have the subdivision survey shall be taken. Okay, so again, the survey here will be done by the DPWH or any government agency or by private surveyors, no? Okay, so letter E, as regards transfer by reason of deed of donation, this must be duly accepted either on the donation paper, or in a separate document by the Department of Secretary or his or her representative, the regional director or the school's division superintendent, as the case may be, provided the same does not impose any onerous condition or burden in the department, and must be duly registered and the appropriate memorandum thereof is annotated in the back of the certificate of that title. Okay? So the plans and specifications for the building to be constructed as well as program of work have been duly approved by the PFCID and the PWS District Engineering Office. Okay, the number 3, the mode of procurement for the regular infrastructure project shall follow the Republic Act 9184, otherwise known as the Government Procurement Reform Act. So whether by the contract negotiated, contract or local administration. Okay, for foreign assisted projects, the mode of procurement shall follow the guidelines of the loan or grant agreement. Okay? So, the location plan for the building to be constructed shall be in accordance with the site development plan as we discussed in the previous unit or the previous part, no? Approved by the school's division superintendent. Number 5, the fund of the construction of the building has been appropriated and certified available. The site has been officially assigned as a public place. Talking about building permits, this is very important. No? A building permit shall be obtained by the owner or school to be facilitated by the contractor for any proposed work to be erected or executed. Okay, constructed, altered, repaired, converted, or demolished a building or structure. The application for a building permit shall be filed in writing in the prescribed form with the Office of the Building Officials or OBO in the municipal or in city. Okay, so provide at least the following information. Letter A, a description of the work covered by the permit. B, description and ownership of the lot as evidenced by certified true copy of the transfer certificate of title, TCT, and the use of or occupancy of the proposed work and estimated cost of the proposed work. Then the last one is environmental clearance certificate or ECC if applicable. So number 4, we have this mode of procurement. And then construction of school building is a form of procurement of infrastructure projects and shall be governed by Republic Act 9184, otherwise known as the Government Procurement Reform Act. The implementing rules and regulations and applicable guidelines or IRR from the GPPB or the Government Procurement Policy Board. As a general rule, procurement of school buildings shall be done through competitive bidding. Okay, so that is most of the time has been done. No? The only exception is negotiated procurement. Now, the GPPB has issued a manual of procurement for the procurement of infrastructure projects as reference guide for procuring entities and their procurement operations effective January of 2007 or 2007. Okay, so number 5, monitoring and inspection. Okay, the DPWH DepEd shall only construct complete school buildings except for multi-story construction, which can be programmed as partial construction if there is a limited budget, or this is what we call as a phase-by-phase construction. Ocular inspections of the proposed recipient school shall be undertaken to assess present site, electrical and water facilities conditions, and to determine actual classroom needs, so as well as the estimated cost or financial requirement thereof. Okay, some pictures of a complete school building are as follows: cemented floor, smooth finished walls, painted walls, ceiling and roofing, full cathedral type ceiling, complete set of windows, 2 entrances with doors, complete electrical wires and fixtures, then roofing or weather protection, and blackboard and toilet as an optional. Both the DPWH and DepEd shall adopt the DepEd standard classroom design as follows: 7 by 7 meter classroom design and 7 by 9 classroom design for schools located in semi-urban areas or in urbanizing portions of municipalities. Okay, so all public secondary schools will adopt the 7 by 9 meter dimension regardless of its class size. 7 by 9 medium rise building, school building design. This will be adapted for schools in the National Capital Region and in urban or high growth areas or where the school is with limited. Okay, so limited space or site. The evaluation checklist shall be used as guide in monitoring SB projects. No? Then number 6, we have acceptance, non-acceptance of school building. After the warranty period, a post-technical inspection shall be done by the inspectorate team composed of the division, PFC, representative from the implementing unit, school principal, school head, or shop teacher, and PTC representative as observers. A certificate of acceptance or non-acceptance shall be used for this purpose. Okay, number 7, the school building card. The individual school building structures, whether permanent or permanent shall have a school building card. This form will be used to fast-track the effective recording and ready reference of a school building card. All schools heads through the assistance of the school property custodian and or the school physical facilities coordinator shall ensure that all buildings, pavilion, stage, and similar structures existing and future construction in schools shall be provided each with individual school building card. Okay, so improvement and maintenance of school buildings. Letter A, repair. Repair involves the remedial work done on any damaged and deteriorated portion or portions of a building to restore its original conditions. You have the minor repairs, okay, is the replacement of the school building components and others, no? Okay, which are estimated to cost less than 10% of the cost of the standard unit. Major repair is the replacement of school building components which are subjected to critical structure loads and stresses and are estimated to cost 10% or more of the cost of the standard building unit. Okay, so rehabilitation is the next one. The rehabilitation of a school building is intended to put back its original or previous condition and involves a general overhauling or a comprehensive repair of the whole building or a major section of it. Okay, so a school building which has been drawn down by the typhoon or destroyed by the earthquake or a flood may be rehabilitated if the estimated cost of rehabilitation is considered economically practical by the appraisal team. Okay, so next we have this renovation and restoration or restoration. To renovate a school building is to make it appear new again. It involves any physical change made on a building to ensure its value, utility, and or to improve its aesthetic quality. Okay, renovation is applied to old buildings which have weathered the years and remained sturdy but need some facelifting to restore their original conditions. Okay, old Spanish school buildings which can be preserved for historical heritage shall be repaired, maintained. They are symbolic of the past and shall be kept for prosperity. Old posts, floors, etc. may be replaced, keeping them close to the original architectural design. Okay, alteration or remodeling. The alteration or remodeling of a school building involves major changes in its architectural design and structure. A building may be remodeled by changing its roof, structure, or modifying its interior walls or reorienting the interior partitions or such other alterations. Okay, so modernization, of course, from the word itself, modernize the school building intended to update its or adapt existing species and facilities. A record generation of mechanical devices used for teaching called educational technology, so on and so forth. The department has to lend itself to the eventual installation of adaptive teaching machines like computer, closed circuit TV or CCTV, language laboratories, and etc. Okay, in the case of the multi-purpose workshop building, its utilization and maintenance are prescribed in DICS or Order number 47 series of 1993. The Bureau of Elementary Education and the Bureau of Secondary Education of the department have developed and published the maintenance of school facilities as guide for school administrators. Okay, the handbook discussed details on maintenance of school facilities. Okay, such as they have here the following. Number 9, condemnation, demolition of school buildings. Okay, so this is in order to clarify procedures in the condemnation and demolition, all school buildings which are perceived to be hazardous, DepEd Order number 48, series of 2000 was issued, contain supplemental guidelines. As a matter of policy, demolition shall be resorted to only when the physical structure is beyond reasonable repairs, it poses danger to the safety of school children, and the school administration can assure continuity of school operations even the structure is demolished. Okay, the following constitute the revised guidelines. Okay, the school head through the school division superintendent and the rest of the inspectorate team for ocular inspections and city engineers, municipal or city engineers, district engineers, and any other if it is available. The building officials conducts an inspection assessment of the building and submit a report recommendation thereof to the official concerned. The school head requests from the school division superintendent for authority to demolish the condemned building based on the report's findings and recommendations of the building officials or the OBO. Okay, if the building is insured, the school head shall inform the insurance firm of the plan to demolish the structure. Okay, so the upon approval, the school division superintendent throughout the regional director or through the regional director forward the request to the central office for further evaluation, so on and so forth. With this report recommendation of building officials, photographs, and then certifications of the issued by the school head. Okay, so PTC or Alumni Association's clearance in case of school building with historical value. Okay, and so on. Okay, the regional office evaluation request conducts inspection if necessary. Number 6, the school head applies for a demolition permit from the building officials. The school head informs the office of the commission on audit resident auditor and request clearance relief from the responsibility so that the structure will be dropped from the account of the school once demolished. Okay, as the building official issues the necessary permit, demolition work is conducted. Upon this completion, number 9, of the demolition, the building official issues a certificate that the building has been dropped from the account of the school. Number 10, priority shall be given to structures already provided with funds for replacement from various sources and shall be ready for immediate occupancy during the school year. Okay, finally, as agreed during the MANCOM meeting on December 20, 2000, request for inspection and demolition of school buildings shall be submitted to the regional office for final approval. Only in cases when the regional director believes that highly technical evaluation of the proposed demolition is warranted shall the request be endorsed by the regional office to the DepEd central office for final evaluation and approval. Okay, so we have these types of school buildings for special cases. Now, the Department of Public Works and Highways, DPWH, through the Bureau of Design, made a study in developing new methods, materials, and design for modern structures that will incorporate features of strength, flexibility, and lower costs. Okay, so we have the following new technology. It's called building construction for special use. ISO panel or DuraQuick system. So we have this, the ISO panel or DuraQuick system is a metal cladding with expanded polystyrene as insulation. The technology can be used for mobile classrooms needed during the emergency situation. It can serve as the alternate to the conventional design at lower cost. The favorable acceptance of this new technology is a testament to its efficiency, aesthetic value, and reasonable cost, factors which are critical in any major investment such as building and facilities. Okay, so materials in the technology met the following requirements. So we have all these requirements here. The structure shall be all weather type and so on and so forth. Then the structures can be built completely in 10 to 12 days including pounding and painting finished. The structure shall be fully insulated against heat and sound. Okay, and an insulation of 50 millimeter styrofoam shall be provided in all walls and ceiling. Okay, the structure shall be fully scaled against water, rainwater intrusion during typhoon. Okay, all buildings components shall be lightweight and can be carried and installed, okay, manually without the use of the cranes. Steel sheath materials for built-up panels shall be 0.45 mm thick. Okay, the structural frame shall be made for structural steel, I-beams for beams and columns. All panels are warranted against defects and corrosion for 10 years. Certificate of warranty shall be issued for its structure. And then prototypes have been tested in the Philippines for at least 5 years and certified by the school principals where it is located. The last one here is plans have been reviewed and approved by DPWH and the DepEd. Number 2, modular type school buildings or PGMA school building. The modular or PGMA type of school building is fast and easy to construct with well-ventilated and properly insulated classrooms. Okay, it has a dimension of 8 by 8 meters. It is advantageous to adapt this building over a 7 by 9 meter classrooms in terms of basic engineering and architectural principle of functionality, stability, aesthetics, and economy. Okay, so the building having an 8 by 8 dimension of classroom is easy to sit in any given school site. It is modular type. Okay, so new or modern technology materials that are easy to transport. Okay, less in cost. The structural stability of the school building was enhanced by the increase of 1 meter in the shorter side. Okay, for one classroom school building, the structural resistance against seismic and wind pressure are equal in both direction attributed by the square floor dimension. Okay, the PGME school building is a product of thorough research and studies by experienced architect with respect to aesthetics. However, aesthetics on building cannot be considered complete by having beautiful shape, comfortable size, and harmonious color combinations, so on and so forth. School building, okay. By the way, modified number 3, modified design of school buildings by the engineering brigade. School children are also vulnerable to acts of terrorism. Okay, so terroristic incidents and their nature of occurrence are so unpredictable that no general precautions on the part of the department and other government authorities can be recommended. In areas with insurgency or peace and order problem, constructing of school buildings are undertaken by the engineering brigade of the Armed Forces of the Philippines. Okay, this to ensure safety for the engineers, architects, contractors, and specialized materials that this type of work shall be handled by the military. Okay. Number 4, the Millennium School Building Designs. The Office of Civil Defense in cooperation with the Department of Education, My Shelter Foundation, Department of Public Works and Highways, Habitat for Humanity, and the United Architects of the Philippines came up with the Millennium School Design. And as a result of the school building design competition all over the world, the winning design is made of bamboo, while the second prize is made of used plastic bags, and the third prize is made up of concrete conventional type. Okay, so the last one here is the NGO constructed school buildings. The construction of school buildings was also opened or made available in non-government organization or NGOs which have the capability and proven track record in the construction of school buildings. One of these in the federation is the Federation of Filipino-Chinese Chamber of Commerce and Industry under the Operation Barrio School Program. This Filipino-Chinese Federation Filipino-Chinese Chamber of Commerce and Industry constructs a 7 by 7 meter classroom designed to much lower cost per classroom through the Bayanihan system. Materials such as sand and gravel are obtained through donations from members and from the LGU counterparts. Okay, so those are the important thing that we should know in the school buildings. Now, I hope and pray that you learn many things in our discussion. Thank you very much.